Hello and welcome to Attacking Species in Chemistry. First of all, let's look at our free radical. A free radical is a species that has an unpaired electron, one or more unpaired electrons. They will attack anything, especially in organic chemistry when nothing will attack. Free radicals will attack even non-polar molecules like alkanes. An example of a free radical is the chlorine free radical, which we know destroys the ozone layer by the free radical colliding with the ozone and breaking it down into normal oxygen. The next type of species is the nucleophile. Phile means attracted to. So it's a species with a lone pair of electrons. It will attack anything with electron deficient carbon. So a carbon in a polar bond where the carbon is attached to another electronegative atom, giving it this permanent dipole. When it attacks, it donates its lone pair and creates a dative covalent bond with the electron deficient carbon. Examples of species include ammonia and hydroxide ions. They both have lone pairs of electrons. The third type of attacking species is our electrophile, and that's opposite to a nucleophile. Phile means it's attracted to, electro means electron dense areas. This time our electrophile accepts electron pairs. You can see here grabbing a pair of electrons, and if we just put a curly arrow onto that, we can see that the electron pair is drawn towards the electrophile. So there's the curly arrow, there's where electron pair is starting, it's going towards the electrophile. And electrophiles tend to be electron deficient. So what do they attack? Electrophiles attack electron dense bonds. Examples of electrophiles are electron deficient hydrogens. These will attract the nucleophiles, the nitronium ion, the acylium ion. These are all examples of electrophiles. And finally, the last attacking species is a base, which nucleophiles under certain circumstances can double up as bases. Bases, instead of attacking electron deficient carbons, will attack electron deficient hydrogens. They will donate a pair of electrons to electron deficient hydrogens. Examples of bases are hydroxide ions. So here hydroxide ion can behave as a nucleophile, but under the right conditions in aqueous ethanol, so if the base, the nucleophile, is dissolved in aqueous ethanol, it will attack weakly held hydrogen atoms. So hydrogen atom is an acid, it will react with a base, and that's why they're called bases, because it is in fact a proton acceptor. Spell that properly. A proton acceptor. Let's quickly look at this concept of curly arrows in organic chemistry. All a curly arrow shows is the movement of a pair of electrons, and curly arrows show where the electrons are starting off, where the electrons are going to. Electrons will always move towards the more electronegative atom. So here, if a carbon-bromine bond breaks, the pair of electrons will move onto the bromine. The arrow has two heads, a double-headed arrow, and that shows the movement of a pair of electrons moving on to the more electronegative atom. We call this heterolytic fission. Lysis means to break. Hetero means end up with different species. So in this case, the carbon, because it's lost an electron that it's shared with the bromine, will get a positive charge. and we call that species a carbocation. And the bromine will now take one more electron than it donated, and the bromine will therefore become a bromide ion. So that is curly arrow showing bond breaking. We call it heterolytic fission because we've ended up with two different species. Let's now look at bond making, and in bond making this time our nucleophile. So let's use ammonia as an example as a nucleophile. There's its lone pair of electrons. It's attracted towards the electron deficient carbon because nitrogen is more electronegative, so there's partial negative charge. So the pair of electrons moves towards the carbon, double-headed arrow touching the carbon atom, and this is showing bond making. And there we have our dative covalent or coordinate bond being formed. If the nucleophile attacks and another group is still attached, that will leave, the bond will break, and that will take its pair of electrons with it. To decide on the mechanism, first of all, look to see if your molecule is saturated or unsaturated. It's saturated if it's got 4 groups around the central carbon. It's unsaturated if there are only 3 groups around the carbon. Methane can only be attacked by free radicals because it's completely non-polar. It can also only undergo substitution reactions because it's saturated. When you have an electronegative atom like a halogen, as in the halogenoalkanes, the carbon is electron deficient, and therefore it's going to be attacked by nucleophiles. Because it's saturated, it's going to undergo substitution. Ethene has got an electron-rich area, and therefore it's going to be attacked by electrophiles. It's unsaturated, so we can add something else, so it's going to be addition. An aldehyde has got an electron-deficient atom because of the electronegative oxygen, and therefore it's going to be attacked by nucleophiles. But because it's unsaturated, things can add on, it's going to undergo nucleophilic addition. Molecule, and looking to see if it's saturated or if it's unsaturated, we can easily predict the reaction mechanism. So for alkanes, we can say they undergo free radical substitution.